Okay, so looking at number 17 is y is equal to x times the square root of 4 minus x. Over on the right here, I have everything that we're going to look at: the x-intercept, the y-intercept, the extrema, and behavior, vertical asymptotes. That should give us a pretty good idea of what's happening. If you haven't already found these, pause the video, go ahead and find all of these parts, see if that doesn't help you, and then come back and see how you did. Okay, all of these different parts, put it together and make one picture. This is something like what we had. So I started with the x and y intercepts. X equals 0, x equals 4. Those are our x-intercepts. And then, of course, 0 is a y-intercept as well, since it passes through the origin. The domain was important because you cannot have a negative square root here. And so it stops right at x equals 4. Does not continue on. The extrema, find the derivative, set it equal to 0, and you find there is an extrema at x equals 8/3. And so I did the first derivative test right here to determine if it were a max or a min, and I determined the max. So then I was able to get this part of the graph right here from just those four things, I guess, huh? And then I need to determine what the y value was at that extrema. So this is me plugging it into the original function. And then I wanted to know, okay, I know it stops here. What goes on the left side of the graph? So I looked at end behavior. And I know it stops at x equals 4. But on the left side, it continues to grow larger and larger in a negative direction. So I know that it didn't end down here. So if you need to pause the video to look at some of this, to study some of this, go ahead and do that now. And then if we take a look at number 68, it says suppose f of 0 is equal to 3, and the derivative is always between 2 and 4, in the interval of -5 to 5. Determine the greatest and least possible values of f of 2. So we are looking right here. Okay, so first of all, if you look at the least possible, that's if the slope is 2. So it's only increasing by 2 y values for every x value, so it's going to go up 4, which puts you at 7. If the slope is moving the greatest, which is 4, it's going to go up by 8, which at f of 2, then it's going to be 12. And that is number 68. If you need to pause the video to look at this, kind of rethink it, go ahead and do that. We're going to take a look at number 90, which all deals with this graph. If you haven't done this, pause the video. Please try this on your own. But over at the right, I have the different questions. It's asking, hey, on this graph, where is the derivative equal to 0? Where is the second derivative equal to 0? So that's your points of inflection on the second one, your relative extrema on the first one. So go ahead and, if you haven't already, like I said, go ahead and answer these questions on your own, then come back to the video, pause it, come back to the video, and let's see what we do. Let's see what we have. Okay, so for the first one, the relative extrema, right? There's 2 of them that I can see, and that's where the slopes go from positive to negative or negative to positive. In this case right here, so x sub 0, and then also right here. But there's also one other one right here. Actually, it's not a relative extrema, but the slope does go to 0, so we have to include that one as well. So those 3. And then this one is the points of inflection. So let's look at the points of inflection, where the second derivative is equal to 0. So that's where it goes from concave up to concave down. Right here, it goes from concave up to concave down. Right there. So x sub 2 is a point of inflection. Also, right here, it goes from concave down to concave up. So x sub 3 is a point of inflection. And we're going to go ahead and answer E as well, x sub 2 and x sub 3, because it's asking the same question. Then the first derivative does not exist. So, okay, hold on. So actually, this would be a point of inflection as well. So yes, so let's include x sub 1. And that, because it does go from concave up to concave down at that point. Where the first derivative does not exist, that would be also x sub 1. Because it doesn't exist at vertical asymptotes, corners, and cusps. And then the max point would actually be at the left endpoint. But this says relative max, so I should have put the word relative in there on D. So the relative max is at x sub 1, right there. It's the highest point on the graph relative to any points around it. And that sums up number 90.